Okay, so create a piecewise function for each scenario, or the following function is continuous. Explain. For part A, we can notice here that we have two intervals. One of the intervals here is x is, whoops, sorry about that. X is less than or equal to 1. The other interval is x is greater than 1. So for the interval where x is less than or equal to 1, it looks like a quadratic function, right? And you can tell by just kind of plugging some points in. So you'll get 0, -2, you'll get the point -2 and -2 and 2. Okay, so a quick way to kind of do this is if you have 0, -2, we can basically do x squared minus 2. That would work, right? And if you test out -2, you'll also get f of -2 here should give you -2 squared minus 2, which is 4 minus 2, which is 2. Okay, so you have to create a function that would involve all of the points on that graph shown. So x squared minus 2 would work for x is less than or equal to 1, right? So f of 1 should look like 1 squared minus 2, which is -1. So we actually have that point. 1 and -1, right? But f of 1 here should not equal 2. Okay, so 1 should not equal 2. So you can already tell that because we have a break, and there's the break here, because we have a break in this function, this is not continuous. I still need to create an equation for the other function. Now you can notice here that at 2 we have 3. At 3 we have 4, at 4 we have 5. Right, so it looks like it's one higher than, the y value is one higher than the x value, so I'm just going to do x plus 1 here. Okay, so this is not a continuous function, guys, right? I'm going to call this f of x, right? And this is basically what our equation will look like. Let's take a look at the next example. So in example B, we can notice here that we have two intervals. So we have the interval x is less than or equal to 1, right? And this basically will look like a piecewise function because it has the signature V shape, right? So it's very important to understand some of the parent functions and what their behaviors look like. The other value here, x is greater than 1, right? Now you could also switch it up. You can make it x is less than 1, x is greater or equal to 1. I'll give you the same result. But you can notice here that the hole that was once here, that was present, is basically being filled by the other equation. So for x is less than or equal to 1, I'm going to make the function resemble an absolute value function. So it's the absolute value of x because it has the points, this is -1 and 1, this is -2 and 2. Right, so it mimics an absolute value function. Beyond x is greater than 1, I'm going to make it a square root function. So I'm going to call it square root x. You can notice here that f of 1 here should be equal to an absolute value of 1. So 1 and 1 exists, but f of 1 should not be equal to the square root of 1, which is equal to 1. So 1 of 1 doesn't exist. So because the point that doesn't exist is filled by the point that does exist, then this is continuous. Okay, so this is continuous as a result. So if you have the same value of y for each of the n values of the interval, then the point will be continuous. So this function therefore is continuous. And this is the equation of that piecewise function.